to, we're doing operations of functions. If you go back to your dash, the standard today is adding and subtracting functions. Okay, you should be able to add and subtract functions after this lesson. It's fairly straightforward. A lot of stuff we're doing at the end there where we are multiplying and plugging things in function notation. Now we're taking two functions saying f plus g. Combine like terms, right? Okay, so that's the kind of stuff we're going to be doing. So sum, difference, that's what we're doing right now. Okay, product, quotient, that's going to be the next couple days. Okay, so just in general, f plus g of x is the same thing as adding f of x plus g of x. Again, that's adding the like terms and combining it to one function. Okay, the difference is the same thing, but subtracting, obviously. Now, order does matter there, right? Addition order doesn't matter. But when I'm subtracting something, my order matters. Okay, what I'm saying is g has to be subtracted because g now is negative. We're doing the negative of g. Okay, so make sure you don't mess that up, okay? All right, so let's look at this here. All right, I got this table here. Let's see, how much do I want to see? All right, so plot the points on the grid. Okay, so we are going to go through this table. It's just telling us a number for the function. That's all it's telling us. And we're just going to work on plotting them, okay? So we know that 4, -7, or sorry, -4, -7, -4, -7. Think about this as x, y, and then another y, like two different y's, okay? Because we have two different functions, okay? So if I go f plus g of x, so that would be -7, -7. So like -14. I'm not sure if they just want us to write the, yeah, just right there. Just put the number -14. You don't have to put the -7, -7. Okay, what's f minus g going to be? What's -7 minus a -7? 0. Okay, and just go ahead and fill that out yourself. You guys can do that. Okay, -5 plus -6. Okay, 1. Okay. Okay. So there they are. Okay, so it says plot the points of x, f of x. Okay, so we're going to plot those points. So that's these points. So -4, 7. -7, excuse me. Right here. And -3, -5. There. -2, -3. So that's roughly what that looks like. Let's see how far does it go. It goes to 4, 9. All right, so there's our line for x, f of x. Let's see how straight we can make this here. Okay, a little bit missed, but not bad. Okay. Now also wants us to do x, g of x. So that's these points. So it starts at the same spot. The -4, -7, so right here. Then we go -6. Okay, then -5. So this one's just going up by 1. here's this one. Okay, so I'll label this one for you. This is x f of x. This is x g of x. Just plot those points. Those are all given. Okay, those are all given. Okay, and we're going to look at the functions now that we created. So now it wants us to go ahead and complete the tables and sketch the graphs of these ones. So the x stays the same. So we're still using all the same x's. Just remember, these are my inputs. This is my different outputs. Okay, output, outputs. Okay, your x that you plug in does not change. That's set. But what outputs from plugging that x in is what changes. So, for example, when I add f plus g for -4, I get -14. So the point for this one is -4, -14. So back to this -4 is all the way down here to -14. The dots are a little bit off today. Okay, so that's where it starts, and then it just keeps going. So -4 or -3, 11, -11. So it's going up by 3s. So 8, 5, 2, 1. Okay, that's your f plus g of x. Okay, and the last one, your f minus g. Okay, is -4, 0, -3, 1. Goes like this, it looks like. 0, 4, 1, 5. Okay. Okay. So that's your different functions. So you can kind of see the relationships of all 4 of those lines and how they change based on what you do. Okay. I'll pause it for a second if you're finishing your sketch. I'm sure your sketch is probably better than mine. Keep going here. All right, so now thinking about the functions f and g on the previous page. So f of x was 2x plus 1, and g of x was x minus 3 if you didn't notice. So f of x had a slope of 2, okay? And then g of x had a slope of 1. We noticed that when we graphed them, right? Up 1 over 1, up 2 over 1. So the expression, what is f plus g then? So then we're going to add, simply, what's 2x plus x? 3x. 1 plus -3, -2. That is what f plus g of x is. That's why if you look at your graph, that one was up 3 over 1. Okay? Oh, f, let's see here. Well, f minus g. What do you think? Fofo, what do you think? What's f minus g? 1x. Good. Plus 4. You guys see that? The one thing he did really good there is he didn't mess up the negative. It's 1 minus a -3. So it's plus 3. So it's plus 4. Good. Whoops. Oh, that's right. So we want f minus g of x. Perfect. Okay, x plus 4. And that's why when we did that graph, it was up 1 over 1. Okay, perfect, perfect. Okay, so it says use a graph calculator to graph the functions. This is kind of, you don't need to do this right now. All you're going to do is you're going to see, oh, my lines are the same. Okay, it's the same as the picture you just put in the front of your book there. Okay, all 4 of those lines. So what is the domain and ranges of these functions? Well, what kind of lines are these? I just kind of gave it away. What kind of graphs are these? They're linear. Linear has no restrictions for x or y, right? Because it grows both directions. Okay, there's no problems for x. Y is a constant because it keeps happening because your graph is going from top to bottom all the time. So this is simply, okay, your x here, here. Okay. Okay, I'm going to pause it here just for a second. I want you guys to try this on your own. What is f plus g of 10? What is f minus g of 10? Negative 10, excuse me. Go ahead and try that. All right, so what do we got? So we plug that 10 into the one above. Aiden, what do you get? 3 times 10? 28. Good. So this one here, 28. Plug it in. 10 times 3 is 30. Minus the 2 is 28. So we plug it in right here. Okay, Lauren, how about for f minus g? Negative 10 into this one. Negative 6. Good. Okay, perfect. And so all this is saying is that can you find a function? These were one apart in terms of their 2x and 1x, like they were the same degree. So you could subtract the like terms. Could you think of something that wouldn't subtract? Okay, or you wouldn't have, you could cancel a term completely, right? So what they're trying to get at is that if I had 4x plus 3 and 4x minus 9, and I subtracted those, the 4x's would cancel because they're the same slope. And so you would just get a actually constant number because the 4x's would cancel. That's all they're trying to get you to think about here, okay? All right, so let's take a step into the quadratics piece of this. All right, let's look at this one. All right, the graphs of two functions, y equals f of x and y equals g of x, are all reals, shown on the grid. The points marked with dots have integer coordinates. So that just means that they're whole numbers. All the dots are whole numbers. Use these graphs to sketch the graphs of f plus g and f minus g. So how could you do that without knowing what the function is? Well, again, when I say f of f plus g, we know what, like if I go to right here, if I go to, let's go to 0. So this right here is this is my f of x graph. This one right here is the g of x graph, right? So if I look at 0 for x, remember, x 0 is for 0 for everyone. What is f of x at 0? 0. What is g of x at 0? 2, right? We just did f plus g of 0, right? 0 is x. We plugged them in. That's what we got. So what's the answer? Okay, 2. So f plus g at 0 will be 2 again. It'll be right there. I know that's confusing. We're mixing. Okay, let's say that one more time. X doesn't change. We have two functions. We need to figure out the outputs for those two functions at 0. The output for f of x at 0 is 0. So I put a 0 here. The output for f of x at g of x, this one, is 2. So 0 plus 2. So that means 0, 2 is a part of f plus g's graph. F plus g has the point 0.02 on it. Okay, let's just stay with it. Let's go with 1 now. We're going to figure out what is 1 for f plus g. Okay? We'll stop after this, okay? We'll finish this up tomorrow. Just hang on there. I know it's another long day. So, what is f at 1? Here's f. Here's 1. It is 0. So f is 0 at 1. Okay, plus what is g at 1? Looks like that one's lying to us a little bit. That one looks like it's, we'll just go 0.5. What's that? Oh, good call. Oh, they go up by 2s. That's a problem. So this is 4, huh? That's okay. We can fix it. Good catch. Okay. So what they just noticed that I didn't notice, this is going by 2s. See 10s here? It's just going by 2s. Everything's fine. All our math is good. All right, so we have 0, 4 for this. So that means at this point, that's a 4. That's all it changes. So then we said 0 and, oh, I see. So we're actually, we need to be here, though. Nope, this is good. This is by 1s. Perfect. Okay. We are by 1s here, by 2s at the y. All right, so if I go right here, here's the 1. That's 0 for f. Okay? And then we're thinking it's halfway between here, so we're saying a 1. That's what we're saying. Are we? See what I'm saying now? The x values are going by 1s, the y values are going by 2s. That's what threw us off a little bit. So your answer here is 1, 1. Let's do one more. We'll do 2. Okay? So what we're doing is we are trying to get points to graph our f of plus g graph. Only f plus g. We're not doing this one right now. So if I plug 2 in, or look at 2 in the graph, here's 2. So the f of x graph, it's at, what's this? 2, 4. Okay? And the last one, hang in there, last one. If I go to 2, the other graph's at -4. So if I add those, 4 plus -4, 0. There's 3 points for the f plus g graph. 3 points for the f plus g graph. Okay, we'll pause there for the notes.